Hi, this is Miss Goodale, and today I'm going to be talking about finding the surface area of a figure. So in the last video, I talked about the nets of a solid figure. The surface area is actually the total area of all the faces of a figure, which is the sum of the areas of the faces. So remember, all of the faces when we did the last video were each of the sides that we drew out here. Okay, we're going to use those to help us find the surface area, which is like if you think about wrapping a present. It would be the paper that would go on the outside of the present if it was in that shape. Okay, so today we're going to focus more on the rectangular prism. A cube will be included in that because it's kind of the same, done the same way. So the first thing I'm going to do, if I have a rectangular prism, then I want to draw out the net to help me. Okay, so these examples we're doing today. I'm going to show you using a net. I'm going to do another video that is another method you might use without drawing a net. Okay, so if I'm drawing a net, I'm going to label it with these dimensions. So if this is 2 meters, I'm going to label this 2. That means this would also be 2 because when I fold it, those two are going to be together. The one right across from it is 2 meters, and that means this one is. And if you think about these folded up, this side and this side are going to match up, so they're going to be the same. Let's label that as 5 meters. And then that leaves my end here. These are all going to be the same. These are all going to be 8 meters. Okay, so the 2 is here and here. The 5 is here and here. 2 is here and here and here and here. 5 is here and here. Okay, so I've gone ahead and labeled. So if this is 8 and 2, then this one, I'm going to label this as number 1. This one is 8 by 5. I'm going to label that as number 2. Then I'm going to label this one next. This one is 2 by 5. I'm going to label that as 3. Now I'm going to look, and I notice this one is also 2 by 5. I'm going to label that as 4. This one is 8 by 2. That one actually matches up with number 1, which I'll label that as 5. And then 8 by 5, 6. So if you'll notice, 1 and 5 have the same dimensions, 2 and 6 have the same dimensions, and 3 and 4 have the same dimensions. So if you folded them, these sides would be opposite each other and on the box. Okay, so that'll come in handy for later. Let's first find the surface area for number 1. Number 1 is 8 by 2, so length times width is my area of one side. So 8 times 2, that's 16. If I go and find the area of number 2, this is 8 here, 5 here. So length times width is 8 times 5, which is 40. Number 3, that one's here. It matches up with that one, so that's 2. And the other one is 5. And 2 times 5 is 10. Now, that gets us the area of each of these. This one is 16. This one is 40. This one is 10. Now, we've done that. Since I said they match up with the other ones, we can just save ourselves a little bit of work and know that if this is 10, then that means this is also 10. Since these two are going to be equal, this one is also going to be 16. And since these two are equal, they're going to be 40. So you should have 2 of each size unless you have a side that is missing, like if you had an open box. Okay? So if I want to find the surface area, I can add these all together. So we have 16 plus 40 plus 16 plus 40 plus 10, and I'm going to put my 10 up here. So if I add all of those up, then I would get 132 meters squared. If you notice, I have two 10s, two 16s, and two 40s. Another way I could have done that is I could have multiplied my 16 times 2, my 40 by 2, and my 10 by 2, and saved myself some time, and added those, and I still would have gotten 132. Okay, so either way I would have done that would work. Sorry. The only thing that you need to keep in mind when doing this is make sure it's not a box with an empty end, because if one of these is missing, you're not going to have 2 for each one. Okay, so only if you have all 6 sides. Okay, let's go ahead and move on to a cube. Now a cube is going to have 6 equal boxes, 6 equal squares. So I'm going to draw 6 squares. And when you draw these, they don't have to be perfect. The area of one side is side squared. So all I have to do to find the area of one side is square that number. This one is 4. So 4 squared, and that's 16. That is 16 centimeters squared. And if I know that each of these is 16, the easiest way to do this, rather than adding 16 plus 16 plus 16 6 times, is to do 16 times 6, and that's 96 centimeters squared. Now again, if I had to do this and had an open side, let's pretend like one of these sides was open or empty. Let's say that bottom side is empty. Then I would only have 5 sides. So it would be kind of like this. And instead of multiplying 16 times 6, I would do 16 times 5. And so instead of getting 96, I would get 80. Okay? So this would be with an open side. Okay, just to let you know, because there may be some problems that do that to you. Okay, let's do another example. Hopefully I have time to do one more. Okay, so I'm going to do this one in a little bit different shape here. And just so you know, it doesn't really matter which ones you match up with each other. I could put my 8 here or here. As long as you have these 3 covered here, then it should come out all right. So this one is going to be 6 times 4, and that's 24. This one is going to be 6 times 8, and that's 48. This one is going to be 4 times 8, and that is 32. Now let's do this one like we did with the cube and pretend like we have a side missing. So let's say we have the 6 times 8 missing. So even if we have that 6 times 8 missing, let's cross this one off. So that would mean I would have these 2 sides that are 6 by 4. So I could still multiply that by 2, and I would get 48. Now the 6 by 8 is the one that I crossed off. So I only have one of those. Then I have the 4 by 8, this here and here. So I can multiply that one by 2, and I get 64. So I add 48 plus 48 plus 64. And I should get, let's see, 160. And that would be labeled in feet squared. Okay. Now if I had the